So students, now let's start a new activity, activity 7.2, equation of a plane in normal form. So our objective for this activity is to demonstrate the equation of a plane in normal form. So now let's see the method of construction for this activity. Step 1. Take a piece of plywood and paste a graph paper on it. Mark points at equal distances on a long nail using a marker. Fix the nail ON on the plywood. Here, the plywood represents the plane and the nail ON represents the vector n, and the nail ON represents the vector n, and the nail ON represents the vector n normal to the plane. Assume O as the origin. So in step 3, we fix the nail ON on the plywood. Here the plywood represents plane and the nail ON represents the vector n normal to the plane. Assume O as the origin. Fix 2 board pins at point A and P. Let P with the position vector R be any variable point. Let P with the position vector R be any variable point on the plane and A be a fixed point. Now step 5, let P with the position vector R be any variable point on the plane and A be a fixed point. So our 6th step is let the plane passes through point A with position vector A and perpendicular to the direction along the vector n. Step 7. So in step 6, let the plane passes through the point A with position vector A. It passes through the point A with position vector A and perpendicular to the direction along the vector n. Take 3 wires and fix them as shown in the figure. So that OP represents vector A, that is OP represents vector A, and OA represents vector R. Then the wire PA represents vector R minus vector A. That is PA then represents vector R minus vector A. So students, now let's see the demonstration for this activity. First, the wire PA, that is the vector R vector minus A vector, lies on plane 1 on representing n vector as normal, to plane 1, n vector is perpendicular to R vector minus A vector. That is, n vector is normal to the plane 1 and perpendicular to R vector minus A vector, that is PA, normal to the plane. So the wire PA, the vector R vector minus A vector lies on plane 1 on representing n as normal, representing n vector as normal to plane 1. N vector is perpendicular to R vector minus A vector. Hence, vector R minus vector A into n vector equals to 0, which gives the equation of the line in normal form. Hence, R vector minus vector A into vector n equals to 0, which gives the equation of the line in normal form. So now, let's see the observation for this activity. Vector A is the position vector of plane 1. Vector R is the position vector of A, and vector n is perpendicular to the vector R vector, vector R minus vector A. 2, that is our second observation. In the first observation, vector A is the position vector of plane 1, R vector is the position vector of A, and vector n is perpendicular to the vector R vector minus A vector. vector r minus vector a into n vector equals to 0 is the equation of the plane 1 in vector form. Hence, we conclude that the equation of a plane in normal form is r vector minus a vector into n vector equals to 0.